Good afternoon, everyone. Today we're going to differentiate two different functions using all of the differentiation rules that can be applied. So for the first one, f of x is x cubed plus 1 all squared times sine squared of x. So we're going to start off using the product rule. And so we're going to do the derivative of the first part. That means using the chain rule. And so we'll have 2 times x cubed plus 1 to the power of 1. The exponent drops down by 1 times the derivative of the expression inside the brackets. The derivative of x cubed is 3x squared, and the derivative of any constant is 0. And so we just get times 3x squared. That's the derivative of the first part times the second part. So times sine squared x plus the first part times the derivative of the second part. Now the derivative of sine squared x means using the chain rule again. Sine squared x is the same as sine of x squared, right? So applying the chain rule, the exponent of 2 multiplies out front. Then the stuff inside the brackets, just like x cubed plus 1 does in the first part, sine x stays where it is. And just like we did with the first part, we multiply now by the derivative of the thing underneath the exponent. That's the derivative of sine x. And so the derivative of sine x is cos x, which we multiply through. And now we can simplify all this down. And so for the first part, we get 2 times 3x squared. So that's going to be 6x squared times x cubed plus 1 sine squared x plus, and here we'll have 2 sine x cos x times x cubed plus 1 all squared, and that is our f prime of x, our derivative function for f of x. There we go. Okay. For the second one, again, more of the same. We're going to look for g. I have no idea what I was trying to write there. Let's try that again. We have g prime of x. So we're going to use, again, the product rule. So the derivative of the first part, which is going to mean a chain rule, right? A square root is the same as an exponent of 1/2, right? So by the chain rule, we get 1/2 times 2x plus 3 to the power of negative 1/2, the exponent going down by 1, times the derivative of the inside expression. The derivative of 2x plus 3 is just 2. So all of this times 2 times the second part. So times the ln of 2x plus 3 plus, now the first part times the derivative of the second part. The derivative of the ln of an expression is 1 over that expression times the derivative of said expression. The derivative of 2x plus 3, once again, is just 2, right? And so that means that, I apologize for this little mishap, g prime of x is going to be, let's multiply this through, the 1/2 and the 2 kind of conveniently cancel out. So I'll have the ln of 2x plus 3. 2x plus 3 to the negative 1/2. The negative exponent means it goes down to the denominator. And the exponent of 1/2 means the square root of 2x plus 3. And then over here we have plus 2 square root of 2x plus 3 all over 2x plus 3. And then we could even cancel out a factor of the square root of 2x plus 3 from the numerator and denominator, and that would actually get us a common denominator, which is kind of a neat coincidence, I guess. So remember, just this is to the power of 1/2, this is to the power of 1, and so this can cancel out, and now this becomes to the power of 1/2, right? And so now we could further simplify g prime of x to the ln of 2x plus 3 over the square root of 2x plus 3 plus 2 over an exponent of 1/2 is again square root, right? And now you see that we have a common denominator, and so we can combine these two terms into one, and we have, let's write the ln of 2x plus 3 plus 2 all over square root of 2x plus 3. And that is an unexpectedly satisfying result. And so there is our derivative function. So I hope this helps. Again, just a few applications of the product rule, chain rules, trigonometric derivatives, derivatives of ln, square roots, exponent laws, all that good stuff. I hope this helps, and thanks for watching.